Greetings. My name is Mike Levis, and I'm an instructor with the Mount Hood Ski Patrol Avalanche Program. The topic of this presentation is human factors. As we have stressed in earlier modules, the AVI triangle data should be used to make a more informed decision. After all, the consequences of a poor decision could be significant. However, avalanche accident data has shown that even with the correct data, people are still making poor decisions. Why is this? The way we use data to make decisions is known as human factors. As you will see in the following, it's one of the most critical factors in avalanche accidents. Let's dig into it and understand why. Our objective for this module are as indicated. First, we'll discuss what we mean by human factors and why they're important. We will then talk about risk and how we make risk-informed decisions. We will then discuss the impact of group size and group dynamics on human factors and decision-making, and wrap up with a discussion of tools we can use to limit the effects of human factors in decision-making. This slide shows some of the trends in avalanche accidents. As you can see from the graph on the left, avalanche accidents have increased continuously over time. This is in spite of the improvements in AVI equipment, such as airbags, and increased levels of avalanche training by outdoor enthusiasts. Why is this? Is it simply due to increasing numbers of people recreating in the outdoors, or is there something more at work here? Also note, avalanche victims tend to be highly skilled in their sport and less so in avalanche skills. Let's define some terms. Hazard is a function of potential impact and exposure. The terrain and snowpack may be susceptible to avalanches, but if there are no people or structures present, the potential impact is low and the hazard is low. Risk is the hazard weighted by the consequences. If there is an avalanche hazard, the consequences to you if you are caught in the avalanche can be high. You could die. Each of us has a risk tolerance, which is a risk level we're willing to accept in our daily lives. After all, if we wanted zero risk, we wouldn't leave our houses. Our risk tolerance in any given situation reflects our attitude towards any hazard we're exposed to in that situation. The risk we perceive in the outdoors is the excess risk above our background level of risk tolerance. When we look at avalanche statistics, an interesting pattern emerges. According to the work done by the Colorado Avalanche Information Center, the primary cause in 85% of avalanche accidents is human factors, as shown in the data on the left. When we look deeper at the data, as shown on the right, the issue in most cases is not lack of knowledge or skills, but poor judgment in decision-making. So the big questions are, why do avalanche victims look at clear signs of avalanche danger but not see them? And why do some victims see and understand the danger signs but ignore them anyway? The answer to these two critical questions is rooted in how we process information and make decisions. Part of the answer is to the key questions we asked in the previous slide has to do with our perception of risk. Our perception of risk will influence what we see or perceive as danger in the environment and can lead us to ignore warning signs. Our perception of risk is heavily influenced by the way we process information. We use heuristics or rules of thumb. These heuristics are based on our experience and allow us to manage the flood of data our senses receive every day. The problem is that heuristics can break down when applied to new situations and lead us to make incorrect decisions. The solution to this is to use a fact-based decision tool to ensure good decision-making. Our brain makes decisions in different ways depending on the nature of the decision, the amounts of sensory input we're receiving, our level of fatigue, and environmental parameters such as temperature and altitude. Our brain has two decision-making systems. System 1, the fast system, and System 2, the slow system. The fast system is used for quick, intuitive decisions. It uses our accumulated base of experience as a reference. The fast system integrates all the sensory data our brain receives and makes many decisions automatically without conscious effort on our part. The slow system is used for more complex problems requiring structured thinking. The slow system will interpret the fast system when we encounter new situations. We'll interrupt the fast system when we encounter new situations or complex problems. However, this requires conscious effort, so it's only used when needed. Heuristics, or rules of thumb, are a critical part of the fast system. The fast system and slow system are interdependent. The fast system sets the parameters for the slow system, and the slow system can override the fast system when necessary. Decision fatigue occurs when we are faced with many decisions over a compressed time frame and our brain fatigues. The slow system starts to shut down and defaults to the fast system. Optimism bias influences the outcome of our decision making and can lead to poor decisions. We'll discuss all of these in the next couple of slides. As we mentioned, our brain has two distinct but interlocked systems for decision making. System 1, or the fast system, makes quick decisions based on intuition and experience. It is used to manage the bulk of our daily decision making, since it can quickly filter through the large amount of sensory data our brain is deluged with daily. System 2, or the slow system, is deliberate and analytical. We use System 2 thinking when we solve math problems, for example. If you had to multiply 17 by 24, most of us would need to focus on the problem to come up with the answer. System 2 thinking is used when we're faced with complex problems or when we're faced with a novel situation that requires consideration. System 2 gets much of its environmental input from System 1. System 2 can override System 1 decisions if appropriate. That's what prevents us, most of us, from saying inappropriate things at the dinner table. System 2 is memory intensive and can be overloaded. If System 2 is overloaded, priority will be given to the most critical decision at the expense of other decisions. So how does this relate to our decision making in avalanche terrain? Avalanches are not normal events consistent with our everyday experience. System 1 thinking will attempt to apply heuristics to sensory input in avalanche terrain and could lead to incorrect decision making. We must train ourselves to use System 2 thinking to override System 1 thinking and be much more thoughtful when traveling in avalanche terrain. We do this by falling back on some of the tools discussed later in this module, red, green, yellow, for example, and by training ourselves to recognize some of the heuristic traps we'll discuss shortly that drive System 1 thinking. Let's start with a discussion of heuristics, since these are the most common traps contributing to avalanche accidents. As we mentioned previously, heuristics are rules of thumb. We develop these rules of thumb as we go through life and develop a base of experience. Heuristics allow our brain to manage the flood of sensory inputs we're bombarded with every day without becoming overloaded. Heuristics guide our decision-making process. The heuristics we have developed help us manage our normal day-to-day activity. Problems occur when we apply these heuristics to unfamiliar situations, like an avalanche. We're slow to modify our heuristic rules. Either they change slowly over time based on reinforcing experiences, or a major event occurs involving significant failures. This slide lists 6 of the most common heuristic traps contributing to avalanche accidents. Familiarity. We rely on past activity to guide our behavior in familiar settings. Consistency. Subsequent decisions are made to maintain consistency with a first decision. Acceptance. We engage in behaviors or make decisions that will get us noticed or accepted by people we like, respect, or who we want to like and respect us. The expert halo. A leader who is perceived to be an expert makes decisions and others follow blindly. Social facilitation. The presence of others leads to a perception of reduced risk, the safety in numbers myth. Scarcity. We value resources, such as fresh powder, in proportion to the chance we may lose them. Let's look at some examples of heuristic traps we might encounter. The first one. We've skied this before. It must be safe, right? How many times have we heard this? This is an example of familiarity. We're in a big group. We're safe, right? This is a great example of social facilitation. Risk tolerance increases since we perceive there is safety in numbers. Other people skied this, so it must be safe, right? Again, familiarity. We've already decided to ski this, so we have to ski it, right? This is a great example of the consistency trap. This is our only chance to see this, so it must be safe. This is an example of the scarcity trap in action. Another decision-making trap to be aware of is optimism bias. Optimism bias is something we all have to some degree. Optimism bias leads us to conclude that bad things won't happen to us. Bad things happen to others, but not us. The problem this creates is that it can lead to increased risk in our decision making. If you have the time, I recommend watching the YouTube video of Dr. Tali Sharot's TED Talk. The link is on the bottom of the slide there. She gives a very entertaining overview of optimism bias. The key to compensating for optimism bias is to come up with processes and checklists to mitigate risk behavior. The last decision-making pitfall we'll discuss is decision fatigue. Decision fatigue occurs when our brains are overwhelmed by a large number of choices that we face during the course of the day. Neuroscience research has shown that we have a finite amount of energy for System 2 decision-making. Once mental energy is depleted, we have trouble weighing trade-offs, setting priorities, and making good decisions. So how do we prevent this? Keeping fueled is a key part of the solution. Your brain needs glucose to function properly, and low levels of glucose will negatively affect decision-making. The other key ingredient is using tools and checklists, as we've discussed previously. This will help offload some of the analysis requirements on our System 2 thinking and will lead to better decisions. So we've discussed human factors in decision-making, how we make decisions, and decision-making traps, and why this is important. In our next module, we'll discuss examples of decision-making traps that are commonly encountered and some tools we can use to compensate for human factors.